All right, guys. So what we're looking at here is finishing up the note sheets from yesterday, our solving systems of equations with three variables. And one of the main ways to solve this is to eliminate it down to a single variable and then go from there. Now, this one here has three parts to it. Determine the number of solutions to the system, state whether the solution or the system is inconsistent, or the equations are dependent, meaning all real, and write the solution set. So we have three parts to it, but to really answer these, we need to solve this here. We need to solve these. Now the first thing we need to do in solving these is to pick a variable to eliminate out of all three. We need a variable to eliminate out of all three. Now, one thing that is nice is that the first equation is only in terms of x and y, the second's only in terms of y and z, and the third is in terms of x, y, and z. So, looking at this here, we need to pick one to eliminate. Now, as I look at all three, and I've looked at this one before, the variable I would pick to eliminate out of all these is either going to be, well, we can eliminate y, or try to do that, or eliminate z, one of those two. Because x is going to be a little bit tricky in trying to get rid of out of the other two. Now, one of the nice things about eliminating z is that, well, for one thing, the first equation already has z gone. We don't have to do anything to it. So one of our two equations that we have will still be 2x plus y is equal to negative 3. Now, one of the other reasons I picked z is looking at the bottom, we have 4z, and at the middle we have 16z. Yes. And we can combine those to get rid of z. Now to do that, well, we can write our first equation here, 2y plus 16z is equal to negative 10. Because whenever we eliminate a variable, we always want the numbers to be the same, and we're always going to go up and match or go higher. So we're never going to try to turn 16 into 4, but we're going to turn 4 into 16. And to do that, to get the z's to be the same, we need to multiply our second equation by 4. So we're going to multiply the whole thing by 4. And we multiply the whole equation by 4. 4 times negative 7z is negative 28, not z, negative 28x. 4 times negative 7x is negative 28x. 4 times negative 3y is negative 12y. And 4 times 4z is plus 16z. And lastly, 8 times 4 is 32. Any questions on this so far? Now that we have the z's matching, we can put this under the other equation. And match up the variables as best we can. Now the variable we chose to eliminate was z, so we need to see if we need to add them together or subtract them. Now whenever the signs are the same, we are going to subtract. Because 16z minus 16z is indeed 0. So we're going to subtract all the way across the board. Now for x, because we don't have anything here, we just have our negative, negative. And our negative, negative does make a plus, giving us 28x. Our next spot, 2y minus negative 12y. Well, the negative, negative makes a plus. 2y plus 12y is plus 14y. Our 16z minus 16z is 0. And lastly, negative 10 minus 32 is negative 42. Any questions on this so far? Now at this point here, we have two equations. we have our original equation, 2x plus y is equal to negative 3, and 28x plus 14y is equal to negative 42. So we need to make another choice. We need to determine if we're going to eliminate x or y next. Which one do we want to eliminate? Y. Now to eliminate y, we need the y's to be the same. Now, if one of these two, so the 28x plus 14y equals 42, we don't have to do anything to it. Negative 42, thank you. That would have made a big difference. We don't have to do anything to it because of the fact that our other y value, the number in front of it, is 1. We can turn it into 14. We don't have to do anything to the 14y. But that does mean that we need to multiply this entire equation by 14 to get those to match. So we're going to multiply our 2x plus y by 14, and we're going to multiply the negative 3 by 14. 14 times 2x is 28x plus 14y is equal to negative 42. At this point here, to get the y's to cancel, we're going to subtract because they have the same sign. 14y minus 14y is indeed 0. 28 minus 28 is, well, 0. This entire side is 0. Is equal to negative 42 minus negative 42. Well, the negative makes a plus, giving us 0. Is 0 equals 0 a true statement? Yes. So what that tells us, determine another solutions. Well, there are infinitely many, because this equation is dependent. There's infinitely many solutions. Infinitely many number of solutions. There's a bunch of them. That will work. Now, there are ways to go about finding what the solutions are. Because for this here, the solution set would be all real numbers, but there are ways to define it. Okay. Yeah. So there's an infinitely many number of solutions. Now, there is a set way that we can write these. Now, when we get to chapter 6, because chapter 5 and 6 are going to go together, there's only 4 sections in chapter 5 that we're covering, and then we'll get to chapter 6. And chapter 6 will deal with matrices. And with the matrices, we can do something called reduced row echelon form. And if we get it in that form, it'll give us these equations that we're going to look at here and give us an easier way to see what the system is. Because even though the system is all real numbers, there is a set number of solutions or a set number of ways that we can find out what some of those infinitely many solutions are. And what we do to get that is we kind of pick a variable, and here we're going to pick, say, y. And what I'm going to do with the first equation is get y by itself. So we have 2x plus y is equal to -3. I can subtract 2x from both sides, telling us y is equal to -2x minus 3. Sorry, I'm going the... I don't like how this is done, but I'm going the wrong way. I want to get it in terms of y. Well, actually, we can do that. I don't know when I did that, but okay. So we'll keep this here. I'm getting it really at this point in terms of x. The book does it in terms of y. What I should have done if I wanted it in terms of y is actually gotten the x by itself, everything equals y. But this works. So what I'm going to do now is get everything in terms of x. So we got the first equation in terms of x. But, because we get that in terms of y, we can get, yeah. And going from here, then, we can use this to get the middle equation technically in terms of x, because I can replace the y and the second one with -2x minus 3 plus 16z is equal to -10. At this point here, we can distribute the 2, telling us -4x minus 6 plus 16z is equal to -10. Well, we can add the 6 and add 4x to both sides. These will cancel. These will cancel, telling us 16z is equal to 4x minus 4. Well, divide everything by 16, telling us z is equal to 1/4 x minus 1/4. But the thing with this is we got everything in terms of x. Now y was our -2x minus 3, and our z is 1/4 x minus 1/4. So really what this tells us is if you give me an x value at this point with these equations, I can give you what the solution is. So I could say 0 for x. And the middle one we would do -2 times 0 minus 3. 2 times 0 minus 3. Well, that's just going to be -3. And lastly, we'd have 1/4 times 0 minus 1/4, which is just going to be -1/4. And this here is actually a solution that will work for all three. Because if we plugged it into the first equation, we'd have, I'm just writing all over the place at this point, 2 times 0 plus -3 is equal to -3. That's 0, so -3 is equal to -3. So that solution worked for the first one. We can look at the second one, 2 times -3 plus 16 times -1/4 is equal to -10. 2 times -3 is -6. 1/4 of 16 is 4. Give us -4. So -10 is equal to -10. We can do this with the third one. -7 times 0 minus 3 times -3 plus 4 times -1/4 is equal to 8. Well, that's here is 0. -3 times -3 is 9. 4 times -1/4 is going to be -1. 8 is equal to 8. So this here is one way that we can actually represent the solution of all real numbers. Okay. Now, in the calculator, we can go through and set up a matrix and do this, and we'll go over that, especially when we get to matrices on how to do that. But the main thing I would say for this here in getting this set up to be able to find the solutions is pick one of these equations to try to get x or y or z by itself, and then get the others in that form as well. And if you do have questions on that, please ask, because we can go back over that together. This is the last problem that we have for this here. Given the non-collinear points 4, 2, 1, -1, and -1, 7, find an equation of the form y equals ax squared plus bx plus c that defines the parabola through these points. Now this here seems like a very challenging problem to try to look at, trying to find an equation of a parabola just given 3 points. But it's actually very interesting in how this does work, because these 3 points work for any quadratic, and they're all in the form of x, y. And what that tells us is, from this equation here, y equals ax squared plus bx plus c, is that when I plug 4 in for x, so a times 4 squared plus b times 4 plus c, I will get a y value of 2. I can, I'll write that, I'd write it a little farther to the side, because we got 2 more. The middle one's telling me that if I plug -1 in for x, so a times -1 squared plus b times -1 plus c, I will get a y value of 1. I have a tendency to do this, and I have a feeling y'all do too, of flipping the x and y values. X is 1, y is -1. And lastly, the last one's telling me when we plug -1 in, we'll get a y value of 7. So we'll have a times -1 squared plus b times -1 plus c. So really, all we need to find from this point here is the values of a, b, and c. Now there is one of these on the homework. And the point I would suggest, okay, we'll simplify this first, and then I will talk about that here in a minute. Now, when I say simplify, well, we do have our number squared in front next to a. So for the first one here, we have 2 is equal to, well, 4 squared is 16a. Then we have plus 4b plus c. Our middle one, we have negative 1 is equal to, well, 1 squared is just 1, so I have a. 1 times b is b plus c. And the last one, we have 7 is equal to, well, negative 1 squared is just 1. B times negative 1 is negative b plus c. Any questions on how we got to these 3 equations here? We good with this here so far? Now, what I was going to say earlier is no matter what the values our 3 points have, there's going to be one term out of these 3, a, b, and c, that's always going to be the same for this problem here. And that's going to be c, because c doesn't have an x with it. So one I would suggest for this type of problem here to eliminate first is c. Now we do need to pick one of these 3 equations to be the eliminator equation, the one we use to eliminate c out of. Do we want to use the first, second, or third? No matter which. We can use the second one here as the eliminator equation. I kind of underline it to remind myself that's the one I'm using to eliminate. Now since c is already matched up, we can just put it under the other 2 to eliminate it out. She saw 3 colors. Get another one. Now I'm going to start with the one on the far right. Since the c's have the same sign, we are going to subtract all 3. So if I go from left to right, 7 minus negative 1, the negative and negative make a plus. So 7 plus 1 is 8. A minus a is, well, 0. That's kind of nice. Negative b minus b is negative 2b. And c minus c is 0. So that actually worked out nicely. We can go on and finish this up in that we get b by itself. We would divide both sides by negative 2, telling us b is negative 4. That's kind of nice. So we found one of our 3 variables. We need to find the other 2. Now we can do the same thing over here. Since the c's have the same sign, we will subtract because c minus c is indeed 0. Now if we start from the left, 2 minus negative 1, the negative and negative would make a plus, so 2 plus 1 is 3. 16a minus a is 15a. And 4b minus b is plus 3b. Any questions on this here? Now the nice thing at this point here is that, well, we already know what b is, yes? So we can take this equation that has 2 variables and plug in the value of b to solve for a. This will tell us that 3 is equal to 15a minus 12. At this point here, we can add 12 to both sides, telling us that 15a is equal to 15. At this point here, we would divide both sides by 15, telling us A is equal to 1. So what's the only thing we're missing? C, yes? Well, we can use the only equation we haven't used. We can use this one here in the middle and say that negative 1 is equal to, well, A, which is 1, plus B, which is negative 4 plus C, to solve for the value of C. Well, 1 plus negative 4 is negative 3. And at this point here, we can add 3 to both sides, telling us C is 2. Any questions on this here before we wrap this up? Are you ready to finish this? Now, the general quadratic equation we started with and we used to get these here was our ax squared plus bx plus c. Well, we said the value of a is 1, so we have 1x squared. B is negative 4, so negative 4x plus 2. Or we can say y is equal to x squared minus 4x plus 2. And that's it. Any questions on any of this here? Now, not every single problem is going to look like all the ones we have, because there are going to be some that are nice. I don't know how the numbers are going to look out for this one here. But we could say 2x minus 4y plus 3z is equal to 15. Then it could tell us that 2y plus 7z is equal to negative 8, and z is equal to 4. Because I've looked through the assignment, there are some that are like this, where it's wanting us to find the solution. Well, one thing that is nice, let me get a highlighter, is this right here. Because one of our solutions is 4 for the solution set. Z is 4. It's already told to us. The last one, z is equal to 4, yes? We can use the next one. 2y plus 7 times 4 is negative 8. I can solve for y. 7 times 4 is 28. We can minus 28 from both sides, telling us 2y is equal to negative 20. Divide both sides by 2, telling us y is negative 10. And last but not least, we can use the top equation. 2x minus 4 times negative 10 plus 3 times 4 is equal to 15 to solve this here. Negative 4 times negative 10 is going to be plus 40. 3 times 4 is 12. I knew I wasn't going to get this lucky. 40 plus 12 is 52. And if we subtract 52 from both sides, 5, 7, we get negative 37. 15 minus 52 is negative 37. And lastly, we divide both sides by 2, telling us x is equal to negative 18.5. And when I said I knew I wasn't going to get that lucky, I was getting 4 whole numbers, or integer numbers wasn't going to happen. If I'd gone with 12 that I was thinking about at the start, might have got it. But, oh well. But that's it. If it gives us one to start with, it's pretty nice. We can go with it and go from there. Any questions on any of this here? That is